Then the shear. So make sure that the scales are the same, okay? If your scale are not the same, I told you, right? You're not going to get more circle, you're going to get more over, okay? And you don't want that. So this is normal stress. Okay. Then you have shearing stress. And the shear stress can be from VQ over IT or TR over J. Okay, either one. 10, 20, 30, 40. And then you have minus 10, minus 20. By the way, today's quiz, you only hand in at 3 o'clock. Okay, I give you more time. It's okay. Okay, so don't stress out. Okay, when you take your time, have lunch. Okay, no eating means no thinking. Okay, so take your time. So all the quiz from now on, we hand it at 3 o'clock. Okay, so those of you who are working, you can hand in at a later time, but you have to let me know. All right. So the first thing we're going to do, so we know that one stress is at 30. Oi. Okay, so one stress state is at 30, right? And then you have another stress state at minus 40. So basically, this is your stress X line, okay, and this is your stress Y line, right? And then you have a shear of 15. So the shear you have to construct both positive 15 and negative 15. Okay. Right. So we're gonna look at X point first. Okay. So if we put at the center is your pivot point. We're gonna look at X. The 15 based on this arrow will generate a clockwise or anti-clockwise. Right? So this will generate a anti-clockwise. So over here, this is point X. Right? There is point X over there because over here is anti-clockwise. Then look at point Y is on the 40 line, right? And then if you look at this arrow now, right? If you have a pivot at the center, right, it's going to generate clockwise. So this is your clockwise, and then over here, this is your point Y. Okay, so from here, you can draw the center of the circle. Okay, you can draw the center of the circle now. Okay, so from then you can immediately calculate the center of your circle. Very standard procedure. So center of the circle is your stress average. So it's equal to stress X plus by stress Y divided by what? 2. So stress X is equal to 15. Oh no, 30. Right, 30 plus by minus 40. Remember I told you they are all vectors, yes or no? Divided by 2 is equal to minus 5 megapascal. Like what you see over here, it exactly intersect the line at the 5 mega. So this is where is your average stress. Okay, so this is where your average stress is. Right? So that's where your average stress is. So you can label this as point O. Okay. So the next thing that we're going to do, we're going to calculate the radius of the circle. Okay. So radius of the circle. Okay. We're going to calculate radius of circle. So this corresponds to your tau max. Okay. So this will be equal to, right? So this will be equal. So this value over here. So from here to here, right? So this distance is equal to what? 15, right? And then the distance from here to here, 10, 20, 30, 35. Yes or no? Right, it's not equal to 40 because we are the center, we are taking from the center of the circle. So it's 15 squared plus by 35 squared. Okay, so this is equal to 15 squared. 38 point. Okay, so it's equal to 38.079 megapascal. Okay, so I do it again, 15 squared plus by 35 squared. 38 point, okay, so 38.079 plus 5, so it's 43. So where it's going to intercept, my principal stress is going to be here. Okay, so 1 point will be over here. Okay, and then the other point will be over here, 33. Okay, I'm just eyeballing. And then it's 38, so 38, again, this is just eyeballing. And then it's 38. Okay, I'm just, so from here, in fact, you don't need to do what I'm doing now. If you have a compass, you can construct a circle. So we are going to construct our Mohr circle now. Okay, so this is our Mohr circle. So I know the height approximately. Left and right. Okay, so over here, we can identify that this is our stress 1 and this is our stress 2. Yeah, and we found our maximum stress, right? 38 point. So next we calculate our stress 1 and stress 2. As I said, you have seen this before. Minus 5 plus by 38.079, right? So this will be equal to minus 5 plus by 38.079 is equal to 33 positive 33.079. And then the next one is minus 5, sorry, plus minus, okay? 5 plus by 38.079 is equal to minus 43.079. Okay? So that's where we calculate our stress 1 and stress 2. So the next thing I want to introduce to you is the rotation of the principal plane. Okay? So what do I mean by rotation of principal plane? Rotation of principal plane such that when we rotate the element, the shear stress is equal to what? Is equal to 0. Okay? So over here, it's going to rotate from point X, it's going to rotate in the anti-clockwise direction by 2 theta p. Okay, we're going to label that as 2 theta p, and I'll tell you why later on. Okay, if you want to rotate from point Y, fair enough. This is also your 2 what? That is also your 2 theta p. Okay, so when that's the case, we are going to find our 2 theta p. So tangent 2 theta p, right? Tangent 2 theta p, so it's equal to what? 15 divided by 35, right? So theta p is equal to 15 divided by 35 inverse tangent 23.2 degrees. Again, this is 2 theta p. And based on the rotation, right? The rotation to 0 shearing stress is going to rotate in a what? Anti-clockwise direction. Oi. It's going to rotate in the anti-clockwise. So theta p is equal to divided by 2, 11.6 degrees. Okay. Why 2 theta p? Okay. Why is it 2 theta p? I can prove why mathematically. You'll be sitting down here for 45 minutes and knowledge gain is 0. Okay. I'm going to explain to you physically what does this mean. Okay. Now, if you look at the element, right? From point X to point Y, what is this angle? Any idea? Anyone?
90.
90 degrees. Right? From point X to point Y on Mohr circle, what is this angle?
180.
So therefore, on Mohr circle, is 2 theta p. On the element is what? That's it. That is the only reason.
What is the P?
Principal plane.
Oh, okay.
Okay, P down here represent principal plane. Okay. For that reason.
So I understand it's the angle there, but what you said something earlier. When we rotate the element by this angle, something will be 0.
Yeah, I'm going to show you that now, okay? Right. So we started with this, right? I'm going to copy. I'm going to paste. All right. We started with this stress field, right? So if we rotate by 11.6 degrees, right, we will have 0 shearing stress because it's the principal plane. Okay, so what do I mean by that? So now I will draw our original axis. Okay, so this is our original axis. Then I'm going to rotate. Okay, we're going to rotate the element by 11.6 degrees anti-clockwise. Okay, I'm going to rotate. So I'm going to rotate this by 11.6. So this is by eyeball. Okay, my daughter took my protractor and I can't find it. So we're going to rotate this anti-clockwise by 11.6 degrees. Okay, so you will have then I'm going to rotate 90 degrees. Okay. So you will have this now. Right? So now I'm going to draw our element now. Okay, now we're going to draw our element tilted by 11.6 degrees. So our element now will look like this. Okay, our element will look like this. So originally, right? Originally, I'm going to draw a horizontal line here and a vertical line here. The purpose I want to do that is to tell you that this is originally my Y point. Okay, this is originally my X point. All right. So on the element, the X from Y to the principal plane is rotating by what? This is also equal to what? 11.6 degrees, right? Rotate in this direction. This is also 11.6 degrees, right? So I want us to focus on point Y. Okay, point Y. So the element I want us to focus on this. I want us to focus on the Y down here that I'm highlighting now, and the Y down here that I've just highlighted on the Mohr circle. Okay. So from Y, right, I'm going to rotate 11.6, or on Mohr circle is what? It's 23.2, right? And stress 2, what is the stress value? It's equal to what? 43.079. So when I construct Mohr circle now on the element now, I know, or we know, that this over here will be compression and is going by 43.079 megapascal. Okay. So the next one I'm going to look at is I'm going to look at point X. Okay, I want you to focus on point X on the element. Okay, I want you to focus on point X on Mohr circle, right? So it's going to rotate anti-clockwise. On the element is 11.6. On Mohr circle is what? 23.2 degrees, right? And this value stress 1 is in tensile. Okay, so this value will be in tensile and is going at 33.079 megapascal. Okay. Is there any shear? There's no shear. Okay. So this is what we call our principal plane orientation, where the shear stress is equal to what? It's equal to 0. So unconsciously, what have you done? What have we done? Okay, unconsciously, what have we done? Now you are capable of doing from element to Mohr circle. So this is element to Mohr circle. And then now you are capable to deal with from Mohr circle and to the what? To the element, right? So now you happen to, hey, now you can do two things now, right? You can go from Mohr circle, element to Mohr circle, then from Mohr circle to element. Okay. Any questions so far? Anyone, please? Okay. If no, I'm going to stop here. Thank you for your time. I know now is usually tutorial, so I tend to teach more. So what I'm going to do at about 12:15 or 12:10, okay, I'm going to post the quizzes, and then you have up to 3 o'clock to hand in. Okay, so I'm going to stop recording now. Okay, I'm going to stop recording now.
Eugene.
Yes.
So is this angle, the principal plane orientation, basically saying that if we have a combined loading and we rotate our element or our whole situation to some certain degrees,
Yep.
then it'll be experiencing pure bending, or
It will expect you only experience normal stress, no shear.
no shear.
Yep.
Right,
So
yeah, sorry.
right. So it's like, remember I was teaching 3CO3 before. This is related to carbon fiber orientation. Carbon fiber can only withstand normal stress. It cannot withstand what? Shear stress. Okay, so that is the direction you lay your carbon fiber.
But isn't it, if you like look at it from a different angle or different like axis, then it depends if it's axial or shear. Like looking at the block from the top, you have a shear stress, but from like the side, it would have like axial.
Yep.
If you know what I mean.
Yeah. So,
So
what
like,
you can see is you also know the orientation where maximum shearing stress will occur. Right?
yeah.
Yeah. So that is the direction that you don't want to orientate your carbon fiber that cannot stand shear stress.
Okay. I had a question. Sorry.
Yep.
Okay, I forgot it.
Right. Okay. Anyone? Any question?
Oh, sorry. I just, what if you have if you're Mohr circle, like your average stress is like in the negative? Is that possible or no? Like it's
Yes.
compressive,
Yes. You can have
and that's
negative.
normal, right?
Yeah, that's normal, right?
Okay.
Yeah, it can be. But again, the average stress, you only locate the center of the circle. Okay.
Yeah.
All right. And I also gave example of how to use it earlier also. Okay. Anyone, any questions? No. So if that's the case, the term test, I'm going to repeat again. The term test is only until week what? Week 6. Okay. I realize if I include week 7, it's not fair for you all because you all have not practiced any questions yet. Okay. So if that's the case, I'm going to stop the lecture here. And thank you for your time. And I'm going to upload the quizzes.